I will use this exercise as an example of the application of queuing theory to stochastically model and design truck hauling operations. We are given a shovel excavator with a known loading productivity and hourly cost. We are also given the capacity, hourly cost, and transit time of the used trucks. The whole operation efficiency is assumed to be 75%. We need to recommend the optimal number of trucks to be used and the resulting expected productivity. We are interested in the optimal number of trucks that result in the least unit cost. We will start to solve this exercise by calculating some operation parameters that are needed for the queuing theory application calculations. This includes the number of this includes the truck loading time, which equals the truck capacity divided by the loading productivity. The inverse of the load time will give us parameter L, which is the arrival rate of trucks in trucks per hour. The other parameter we need is arrival rate A, which is the inverse of the transit time. The queuing parameter R is calculated as A over L, and it is 0.1. As we discussed in the lesson video, the approximate balance point is the inverse of R, which is around 10. So our analysis will evaluate the production and cost performance of whole crews around the balance point to account for the operation variability. We will use this table format to analyze the crews of 8, 9, 10, 11, and 12 trucks. It seems like a lot of work, but it is very simple and repetitive process. For each scenario, we'll identify its PT value from the shown table using the number of trucks, N, and the R factor. Remember, PT is the probability that there will be a truck available to be loaded at any given time. We see that the more trucks we have, the higher the probability that the shovel will be busy at any given time. We will use the third column to calculate the hourly production by multiplying PT, the shovel loading rate, and the operation efficiency. For the same operation, the loader production and efficiency are constant. The production is basically dependent on the PT value. We will use the third column to calculate the hourly production. We'll calculate in the fourth column the crew cost that includes the hourly cost of the shovel and the trucks. In the last column, we calculate the operation cost performance or unit cost by dividing the hourly cost over the hourly production of every crew scenario. We conclude this exercise that the optimal crew will include only 9 trucks because they provide the least expected unit cost.